In question 9, the equation of a curve is y equals to 3x plus 1 minus 4 into 3x plus 1 to the power half for x greater than negative 1 upon 3. We have to find dy dx and d square y upon dx squared. So in the first step, finding dy dx. So the derivative of 3x will become 3. 1 is a constant, so it will become a 0. To differentiate 4 into 3x plus 1 to the power half, we'll multiply half by minus 4. So 4 will multiply by half. 3x plus 1 will remain as it is, and the power will decrease by 1. So this will become minus 1 upon 2. We can simplify it to write it as dy by dx is equals to 3 minus 2 into 3x plus 1 to the power minus 1 upon 2. And we also multiplied by the derivative of 3x plus 1, which is 3. So multiplying it by 3, the final answer will be 3 minus 6 into 3x plus 1 to the power minus half. To find d square y upon dx square, we differentiate dy dx again. So d square y upon dx square. So derivative of 3 will be 0. Minus half times minus 6 will become a plus 3. So minus half, minus 6 times minus half, bracket 3x plus 1. So minus 1 upon 2 minus 1 will become minus 3 upon 2 multiplied by 3. So this will be 2 1 times 2 3 times. Minus minus will cancel out. So the final answer will be 9 into 3x plus 1 to the power minus 3 upon 2. In part B, we have to find the coordinates of the stationary point of the curve and determine its nature. So as dy dx was 3 minus 6 into 3x plus 1 to the power minus 1 upon 2. At stationary point, dy dx is 0. So first we'll write that dy dx was equals to 3 minus 6 into 3x plus 1 to the power minus half. We'll put it equals to 0 and then find the value of x. So we'll write 0 is equals to 3 minus 6 into 3x plus 1 to the power minus half. Taking this on the other side, we can write it as 6 and keeping 3x plus 1 in the denominator to make the sign positive. This will become 6 upon 3x plus 1 to the power half is equals to 3. Cross multiplying, we'll get 6 upon 3 is equals to 3x plus 1 to the power half. Now taking the square on both the sides, so 3 ones and 3 twos will become 6. Now to get rid of the power 1 upon 2, we'll square both the sides. So this will become 4 is equals to 3x plus 1. So 3x will be equals to 3 and x will be equals to 1. Now as we had to find the coordinates, which means we'll also have to find the y value. So the equation was y equals to 3x plus 1. So the original equation was y equals to 3x plus 1 minus 4 into 3x plus 1 to the power. So it was to the power 1 upon 2. Substituting x equals to 1, we'll get y equals to 3 plus 1 minus 4 into 3. 1 times 3 plus 1 will become 4. Square root of 4 will be 2. So y will be equals to 4 minus 4 into 2. So the value of y will be 4 minus 8, which is minus 4. So the coordinates of the stationary point will be, so 4 minus 8 will become minus 4. So the coordinates of the stationary point will be 1 comma minus 4. And in the last part, we have to determine the nature. So to determine the nature, we'll substitute this value of x in the double derivative that we found out, which was 9 into 3x plus 1 to the power minus 3 upon 2. So to find the nature of the stationary point, we will use the expression for d square y dx square, which was 9 into 3x plus 1 to the power minus 3 upon 2. Substituting x equals to 1, we'll get 9 into 3 into 1, which will become 3 plus 1 to the power minus 3 upon 2. So this will be 3 upon 4 to the power 3 upon 2. As this will be greater than 0, the nature will be a minimum point.